Hello, hello. Today's video is about the sine rule. This is going on page 23. And you want to make sure you get down your goal. You guys will be able to find angle measures and side lengths of non-right triangles. So we use SOHCAHTOA to determine side lengths and angle measures of right triangles. But not every triangle we're going to run across is going to be a right triangle. So for those, you have two different rules. You'll have sine rule, which you'll learn about today, and then you have cosine rule, which you'll learn about on Tuesday of next week. Okay, so on page 23, make sure you title it sine rule, make sure you number page 23, and make sure you get down to goal. Okay, so you remember that half sheet that we had from last class? Well, you're going to need to pull that out of your pocket, and what you're going to need to do is you're going to need to fold it a hamburger style in half, and then you're going to need to cut it. Okay, so basically from that half slip of paper, you're creating two halves now. Okay, and you're only going to work with one half. So that extra half, just go ahead and put it back in your pocket because we're probably going to use that later on down the road. Okay, so that little half slip, that half of a half slip now, okay, should almost be like shaped like a square. What you're going to do is you're going to fold it a little bit to create another tab. Just like how we did for this right here on the last foldable, how we created that little tab there, you're going to do that again, okay? So you're going to make that fold, okay? And then you're going to open it up. And then on that fold is you're going to put the following, okay? So this is what you should have, right? This right here should represent the fold. And on the actual little tab that you create, you're going to label it law of sines. And then on the actual flap itself, you're going to you're going to write down the formula for the law of sines, which is what you see here. A over the sine of A equals B over the sine of B equals C over the sine of C, or vice versa. You can have the signs on the top and the lowercase letters on the bottom. So go ahead and write that onto your flap, okay? But basically it should look like this. Your paper should literally look like this, okay? If you're just utterly and completely confused, you can look at my notebook. I do have an example of what I was trying to describe to you guys in my notebook, so you can have a look for yourself if you need to. But basically, these are proportions. You're not going to use all three parts of this proportion at one time. You're only going to use two, based off of what you have in your actual picture, in your actual question. Okay, when you're using the sine rule. Now, there's a difference. So you have sine rule, you have cosine rule. When do you use which? Well, for sine rule, you're going to use them in these two following situations. Now, on your particular little flap, what you're going to do is you're going to flip it up, okay? So all of this writing that you see right here is going to be on the front side. Flip it up, and you're going to write this on the back side, okay? So this is pretty much what you should see when you flip it up. And you're going to write when do you actually use sine rule? You use sine rule when you have two angles and one side, and of course that side has to be across from one of the angles, and then two sides and a non-included angle. Now, non-included basically means this. If you notice, all the lowercase letters represent side lengths. Okay, so in the formula, all of these lowercase letters represent the side lengths of your triangle. The capital letters represent your angles. So as you can see here, sine A, sine B, sine C, all of those were basically signs of an angle. So your two sides in a non-included angle would be something like if I had side A and side B, the non-included angle could be angle A or angle B. Because if you look, C is the angle that's in between those two sides, A and B. So you could not use sine rule if you were given side A, angle C, and side B. That is not two sides and a non-included angle. But if you were given side A, side B, and angle A, then you could use the sine rule. Okay? If I gave you side C and side A, what angle would be the non-included angle? Think about it. Answer it. Hopefully you said angle A or angle C, okay? Because C and A, B would be the included angle. So you could not use B. It has to be a non-included angle, such as A or C. So this is your foldable, okay? It's very basic, very simple. It's called a flat foldable. And what you're going to do is you're basically going to glue it down now, okay? So on the back side of the law of sines where you wrote it, you're going to put some glue right there, and you're going to glue it right underneath your goal. Okay? We do have 3 examples that are going to describe a sine rule, the law of sines. So you want to make sure that when you glue it really close up to the goal. So in that way, you're going to flip it up, and then you're going to put your examples underneath it. Okay? Again, if you need to, look at my notebook to see a model if you're just utterly and completely confused on how I want you to do this particular page. So like I said, you have 3 examples. Here's the first one. Again, 3 examples. If you want to kind of have an idea of what they look like, you can fast forward through the video so you can kind of see exactly how much space you'll need, but you'll have 3 examples. So here's the first one. In triangle ABC, B is 16 centimeters, C is 10 centimeters, and B is 135 degrees. You need to represent this information in a labeled diagram. You need to find the size of angle C, and hence find the size of angle A. So the first thing is we got to draw a picture. Okay, so we need a picture. And pictures are always helpful because you want to have an idea of what type of triangle that you're dealing with. Okay. And if you notice, I definitely have an obtuse triangle because angle B is 135 degrees, so I'm going to label that. And then I'm going to put in A and C. And it really doesn't matter where A and C go as long as we put these side links across from the respective angles. So side B, that's 16 centimeters, is going to go across from angle B. Okay? Remember, the side links go across from the angles based off of the picture. And you won't always be given A, B, and C, but you should be able to label the triangle based off of, whatever the letters are of the triangle. And side C goes across from angle C. So it'll be there. And there is a diagram, a labeled one, to represent your information. Now for part B, it says find angle C. This right here. If you look, we have the situation of 2 sides and a non-included angle. So we would use sine rule here, okay? And what part of sine rule are we going to use? We're actually going to use this part right here. We have side B, we have angle B, we have side C, but we're looking for angle C. So we're going to use that part of the formula. Okay, I am going to kind of shorthand this just to save a little bit of time here. Okay, I'm going to copy this over and put it here so you can kind of see what I'm doing. So to answer part B, I'm going to use this formula and I'm going to plug in everything that I have. Side B is 16. I'm going to divide that by the sine of angle B. And then I'm going to set that equal to side C, which is 10, and I'm going to divide it by the sine of angle C. Okay, that you see here. And then basically what I'm going to do is I'm going to go about and solve this proportion. And how do you solve proportions? Exactly. Hopefully you said cross multiply. I said exactly like, oh yeah, they're responding to you, Ms. Anderson. I hope you are. Okay, you should be not just mindlessly copying, but you should be, actively trying to answer some of the questions that I'm proposing to you. So you'll have 16 times the sine of C equals 10 times the sine of 135. Okay. Now, before you start trying to type into your calculator, okay, what is 10 times the sine of 135? Just hold off for a second, okay? Just hold off for a second. Let's go ahead and let's just solve for C. In order to solve for C, we're going to divide both sides by 16. So we'll have 10 sine of 135 all over 16. And then, because we're looking for an angle, remember, whenever we're looking for an angle, we need to take the inverse. So to find the value of angle C, we're going to do sine inverse, or sine to the negative 1, of that entire fraction. Okay. Now make sure that when you type it in, you let the calculator know that you want to divide the entire numerator by 16. So basically what I have typed in is pretty much what's going to show up in your calculator. Actually, let me include another set of parentheses because I'm pretty sure that's what's going to happen. And that's what you should type in, okay? 10 times the sine of that looks good. And so when you type that in, you will get your answer for angle C. And so when you type that into your calculator, and hopefully you're on degree mode, you'll get that C is about 26.2 degrees. okay? And I'm not going to go through and try to pull up the degree symbol. It's just going to be too much, so I'm just going to type in the word degree. So hopefully you got that. And hopefully you see how you can use the sine rule to set up the proportion, cross multiply, and solve it respectively, okay? Now, I strongly suggest that you guys show your work because that's where the method points are going to come in, okay? Now, for part C, it says, hence, find the size of angle C. Hence, anytime you see this word, that basically means that you can use previous work that you already did to find the size of angle A. And if you think about it, how many degrees are in a triangle? I hope you are again participating and realize that, hey, there are 180 degrees in a triangle. Okay, so you can do 135 plus angle A plus angle C equals 180. Well, we just found out that angle C was about 26.2 degrees. It's still sitting in our calculator, correct? Hopefully so. So what you should do is you should add 135 to the number that's already sitting in your calculator. And when I do that, I get 161.2278 and some change. And then what I'm going to do is I'm going to subtract that number from 180. Now, do you have to show out all the steps that I'm typing in right now? No, you do not, okay? But I'm just trying to show you guys that, hey, this is exactly what I'm doing, okay? So I'm going to subtract that previous answer that I have in my calculator to find that angle A is 18.8 degrees, okay? I am not rounding before I get my answer, and that's what I want you guys to do, all right? So your answer to part C is 18.8 degrees, and your answer to part B is 26.2 degrees, and your picture is what you see there. Here's example 2. Go ahead and write this down, and then press play when you're ready to follow along. In triangle PQR, we're looking to find the length of RQ. Give your answer correct to 2 significant figures. It tells us how it wants us to round, so that's exactly what we're going to do, 2 significant figures. All right, I'm going to go ahead and label my triangle with all the remaining pieces, just so that way you guys can see how you can still use the sine rule even though you don't have A's, B's, and C's. So here's a situation where we have 2 angles and a side. Okay, so you had one scenario, which in example 1, and now you have the other scenario where you're going to use sine rule when you have 2 angles and a side. All right, now if you notice, the side that we're looking for, which is essentially side P, we don't know the angle across from it yet, but we can find it. In order to use sine rule, we need to have the angle opposite of the side that we're looking for. So in order to find angle P, we're going to add the other 2 angles. Okay, we're going to add the other 2 angles, and we're going to subtract it from 180. Because again, there's 180 degrees in a triangle. So then that means that angle P is going to be, did you figure it out, or are you waiting for me to do it for you? Okay, figure it out. That's right, it is 78. Good. Okay, so that's 78 degrees. Now that I have my angle across from the side I'm looking for, you see how I have a side and the angle across from it, the 82 degrees and the 10 kilometers? Well, I'm going to use that along with my sine rule here, okay? Now, yes, in the original formula that's in your reference booklet and that you have written down on your little flap, it's going to have A's, B's, and C's. But we can change that, guys. We can say this is P over sine P equals Q, lowercase q, over sine Q. Okay, it does not have to be A's, B's, and C's. Okay, we can change it to any letter that we want to as long as we stay consistent. Q goes with Q, P goes with P, etc., etc. So now that we have that, let's plug everything in. We're looking for side P, and we have angle P, which was 78. And then we have side Q, which is 10, and we have angle Q, which is 82. Right? And now we're going to solve the proportion the same way that we solved the other proportion from example 1. We're going to do the exact same thing here. We are going to cross multiply and we're going to solve. So when we cross multiply, we'll end up getting P sine 82. So P times the sine of 82 equals 10 times the sine of 78. To solve for P, you guessed it, we got to get it by itself. So what we're going to do is we're going to set We're going to divide both sides by the sine of 82, and we're going to have 10 sine 78 divided by the sine of 82. And that is what we're actually going to end up typing into our calculator. Now you want to make sure that you're typing it in and you're getting the same answer that I'm getting. So right now I want you to type this into your calculator, and I want to make sure that we are getting the same answer. Okay, so take a moment and type this in, and then when you're ready to see what the answer is, you're going to press play. Did you get 9.88 kilometers? I hope so. That's what I got. All right. And essentially it does make sense because isn't 78 degrees less than 82 degrees? Yes, it is. So that means that side P should be smaller than side Q, which it is, okay? Not by much because 78 is only a little bit away from 82, so it should be, still smaller, but not too much smaller. And if you wanted to find side R, even though it didn't ask you to, you want to make sure that R is the smallest side out of all three sides. And you know what? I just caught it, and I wonder if you were saying it in your mind. Hey, Ms. Anderson, we're supposed to round to two significant figures. So if it was 9.877, two significant figures would be 9 and 8, and then that 7 would have cost us to round this number, this 8 up. So our actual final answer is 9.9 kilometers. I caught that. I'm glad I did before I went to the next example. All right. So on this one's on you. This is your last example that's going to go on to this page, page 23. And so really, guys, give it a try. Okay, give it a try. Answer part A, answer part B, answer part C. And then when you're ready to see the answer, press play. All right. Are you ready? Okay. Hopefully you're able to find the first one, which says that write down the size of angle BCX. Okay. Well, BCX is this angle right here. BCX, this angle right here. And if you recall from your geometry days, a straight line has 180 degrees. So you're going to take a 180 and subtract it from 30 to get 150. And that is the size of angle BCX. Now we need to find the size of BCX because in order to find part B, which was side length BC, we needed to know what that angle was. Okay, so we know that this is 150. Now, in order to find side BC, we can use the sine rule because then this would be we have two angles in the side. Okay, this is definitely sine rule, and this is definitely not a 9-degree triangle. This angle BCX. So what we need to do is we need to find angle CBX in order to use the fact that we know that this side over here is 10 centimeters. So we'll basically subtract 150 and 10 from 180 to get that angle CBX is 20. And so now that we have that, therefore, we can use the sine rule to say that BC, aka side X, divided by sine of 10 equals 10 divided by the sine of 20. Then we can cross multiply, divide both sides by the sine of 20, and type that into our calculator to get our answer for BC, which you should have gotten as 5.08 centimeters once you round to three significant figures. Okay? Now, don't clear out your calculator just yet because now we have to find AB. AB is this side of this right triangle. Did you know this is a right triangle? Yes. So because it's a right triangle, we can use SOHCAHTOA. Anytime you have a right triangle, use SOHCAHTOA. It will save you some steps, and it will save you some time than trying to use sine rule or cosine rule over again. Okay? So AB is the opposite side based off of 30 degrees, and BC is the hypotenuse that we just found. So we're going to use sine out of the SOHCAHTOA, okay? Because we're looking for the opposite side and we have the hypotenuse. So when we set it up, it's going to be sine of 30 degrees equals AB over the 5.08 number that we still have in our calculator. That's why I put 5.077 repeating, okay? Because again, if we have to use an answer for another part of the question, we do not want to use the rounded answer. So in order to solve for AB, we're going to multiply both sides by the denominator to get rid of it. So AB is going to equal 5.077 and whatever the rest was, times the sine of 30. And then we're going to get our final answer of 2.54 centimeters, which is the length of AB. And there you go. That's the sine rule. I hope it wasn't too confusing or too challenging for you guys. Your homework is going to be pretty much just on Sine Rule, and you're going to start on that now. Hopefully, you still have some time in class to get started. You guys can work together if you have any questions. Um, and of course, if you have any questions for me, you can always shoot me a message on Schoology, all right? So, you guys, go ahead and get started on your homework. Have a great weekend. Bring your questions to class on Tuesday, or you can always message me or text me, all right? Have a great weekend.